Hello everyone. In this video, we'll be seeing the topic of Hasse diagram. Hasse diagram, we can draw this graph only for a partial order relation. Hasse diagram is nothing but it is a digraph. Digraph, it is called as directed graph. So for a graph, we already know that we need vertices and edges to draw a graph. Directed graph means additional to these vertices and edges will be having directions also. So here we have to know from the partial order relation which we are going to fix as vertices and which one we are going to fix as edges. Vertices is nothing but the elements in the given set, and if we want to draw an edge between two elements, then we have to say those two elements must be related on the given partial order relation. So drawing directed graph is in this method. But to find the Hasse diagram, three important steps are there. Since all the partial ordering relation is a reflexive relation, every element will be related to itself. So we will be having a self loop. For example, if I have an element A, since partial order is also a reflexive relation, A element will be related to itself. So every element will have a self loop. Since all the elements has this property, in order to reduce complexity, we can remove these self loops. That is the first step. And also observe that partial ordering relation is also transitive. Transitive in the sense, suppose if I have an edge between 1, 2 and 2, 3. Also I am having an edge between 1, 3. So I need not represent this edge 1, 3. It is enough to represent the edge for 1, 2 and 2, 3. Because if we have these two edges, we can come from 1 to 3. So due to transitivity, the edges which are present, we are going to remove that. That is our second step. And in last step, we know that all the edges should be in the form of upward direction. So if we have in upward direction, we need not show the direction of the edges. So these are the three steps to draw the Hasse diagram. The three steps, it is nothing but removing all the loops and removing all the edges that are present due to transitivity, and also we are going to draw an edge without arrow mark. Without arrow mark means we are going to remove the direction. So we have to fix the initial vertex at below and terminal vertex, that is the last vertex at the above. This is how we have to draw the Hasse diagram. Let us see the first problem. Construct a Hasse diagram for the partial ordering a comma b such that a less than or equal to b on the set 1, 2, 3, 4. So the given set A, we can take it as 1, 2, 3, 4. And the relation mentioned here, R, we can take the relation as R. Relation R is A less than or equal to B. Clearly we know that 1 will be less than or equal to 1. So 1 is related to 1 and 1 is less than or equal to 2. So we can write 1 comma 2. Similarly we can write 1 comma 3 and 1 comma 4. If we come to the element 2 comma 1, 2 it is not less than or equal to 1. So we cannot write 2 comma 1 element in the relation. But 2 comma 2 it is possible, 2 comma 3 it is possible, 2 comma 4 it is possible. Similarly 3 1 we cannot include, 3 2 also we cannot include inside. So 3 3 we can include, then 3 4. So last one, 4 1 will not be there, 4 2 will not be there, 4 comma 3 is not there, 4 comma 4 it is possible. So this is the relation. For this partial ordering relation only we are going to draw the Hasse diagram. So note the point, always we have to place the vertices in upward direction. Here, observing the relation, we can easily find that the initial vertex will be 1 because 1 is the lowest element. So, I am going to fix 1 here. This is the first element 1. And next entry, I am going to fix 2. So, clearly 1 is related to 2. So, we have to place 2 above this point 1. Next one, we can come for the element 3. So, we can observe that 1 is related to 3. Similarly, 2 is also related to 3. So, we have to place this 3 above the points 1 and 2. So, I am going to place 3 here. Next one, we are going to fix the element 4. Observe that 1 is related to 4, 2 is related to 4, 3 is related to 4 and similarly 4 is related to 4. We are going to place this 4 above all the entries. Now we have to put the edges. So observe that 1 is related to 1. So we'll have a self loop. This one. Next one is related to 2. So we'll have 1 comma 2 edge. This is possible. Next 1 comma 3 is there. So we have to put 1 comma 3. 1 comma 3 is there. Then 1 comma 4. This is 1 comma 4. Next one 2 comma 2 it is present and then 2 comma 3 is there, then 2 comma 4 it is present. So then 3 comma 3, 3 comma 4, at last it is 4 comma 4. So this is the directed graph, required directed graph. From this directed graph only, using all those steps, we are going to reduce the directed graph to Hasse diagram. So step 1 is nothing but step 1. It is removing all the self loops. So we already know that 1 will be placed below, 2 it is here, 3 it is here and 4 is here. So 1, 2, 3, 4. If I remove all the self loops, apart from that I will be having an edge from 1 to 2, 1 to 3 and then 1 to 4. Next one 2 to 2 we can remove it since it is a loop. 2 to 3 will be there, then 2 to 4 it is there, then 3 to 4 is there. 3 comma 3 we can remove, 4 comma 4 we can remove. So this is the figure we get in first step. Then in step 2 we are going to remove all the transitive edges. We are going to remove all the transitive edges. So we can fix all the vertices. It is 1, this one will be 2, this one it is 3 and this one it is 4. So we know that from 1 to 2 there is an edge and 1 comma 3 is there. So we have to see whether we can reach this 1 comma 3 in any other way. If I join the edge 2 comma 3, I can reach 1 comma 3 like 1 to 2 and 2 to 3. So no need to draw this 1 comma 3 transitive edge. Similarly, if I want to draw this 2 comma 4, I can come from 1 to 2, 2 to 3 and 3 to 4. 3 connections are there. So 1 comma 4 transitive edge also we can remove. The next transitive edge is 2 comma 4. 2 comma 4 we can come in this manner. So it is 2 to 3 and 3 to 4. So we can remove that 2 comma 4 transitive edge also. Then 3 comma 4 alone it is there. So this is the diagram we will be getting after step 2. Next one, In step 3, that is step 3, we are going to remove the directions. Since we can observe all the directions are in upward way. So we can remove the directions. Even if we remove the direction, we can understand that all the elements will be placed above the previous one. So here our diagram will be, it is 1, this is 2, this is 3 and this is 4. So 1 to 2 an edge will be there, 2 to 3 an edge is there, 3 to 4 an edge is there. So this is the required Hasse diagram. We can observe that compared to the first drawn directed graph, this is very much simpler. So Hasse diagram is to obtain the partial order relation or to represent a partial order relation in a graph manner in simplified form.